All right, so now we're going to go through example number 1 from 13.4. It asks us to find all possible values of sine inverse of root 2 over 2. And we're going to use our unit circle for this, so hopefully you've got that with you. Let's take a look. So backing up just a second before we get into this example, remember we can use the unit circle to evaluate sine, cosine, and tangent for different degrees, angle measures really, whether that be in degrees or radians. So for example, if I wanted to, say, find cosine of 60, well, what we have to keep in mind is that cosine, we think of that as the x coordinate of all these points, and sine is the y coordinate of all of these points. So if we were to find cosine of 60, we would just look at the x coordinate at that point, and there's our answer. So cosine 60 is 1/2. So we're going to be using the unit circle and going the opposite direction using our inverse trig function here of sine inverse. So to figure this out, we're going to be looking at the y coordinates. Since we're looking at sine, we're going to find all the places where the y coordinate comes out to be exactly square root of 2 over 2. Okay, so let's start here in this first quadrant, looking at the y values. We've got 1/2 root 3 over 2, and then right here in the middle is square root 2 over 2. So that's what we're looking for. That means that we're going to start constructing our answer, and it's going to be pi over 4. We're going to write our answer in radians here first, same way the book does it, and then we'll talk about degrees also. But our first part of the answer is pi over 4, meaning sine inverse root 2 over 2 equals pi over 4. That's our theta. That's our angle that gives us the ratio of root 2 over 2. Now, it's not the only spot on the unit circle that gives us that y value. We can go over here to quadrant 2, and the y value is again square root of 2 over 2, which means we have a second angle. We have 3 pi over 4 also gives us that same y value. If you go down to quadrants 3 and 4, then you can see your y values become negative root 2 over 2, negative root 2 over 2. So it's close, but it's negative, and that's not what we want. So second answer is 3 pi over 4. I'm going to write that down here. And the reason I wrote that down there is because these are not our only two answers. So it says find all possible values of sine inverse root 2 over 2. Well, we know that if we're at pi over 4, we could also end up in that same spot by going, let's say, backwards around the circle. We could go clockwise, starting from our initial side here, go all the way backwards, and we'd be going back, let's see, that would be pi, 5 pi over 4, 6 pi over 4, 7 pi over 4. So if we went negative 7 pi over 4, we would end up in the same spot, giving us that same y value of root 2 over 2. So when we're writing these answers, when it says find all possible values, we have the ones that we can see on the unit circle, but then we also have every single coterminal angle to that original angle. So we can't list all the coterminal angles because, at pi over 4, I could just go around the circle again, end up at the same spot, go around the circle again, go around the circle again, and there's infinite. So instead of trying to make a list, what we do is we say we have pi over 4 as our first answer. Then we're going to add 2 pi to that. If we add 2 pi, we go all the way around the circle again, finding that coterminal angle. So we could go 2 pi over 4, sorry, not 2 pi over 4. We could add 2 pi to our pi over 4. Then we could add 2 pi again and add 2 pi again as many times as we want. So we're going to add 2 pi n, where n is any integer. It could even be negative, which would mean that you go the opposite way around the circle. So 2 pi n takes care of finding all possible values of sine inverse root 2 over 2. And let's make a note there. N is any integer, positive or negative whole number. And so we'll do the same thing with our 3 pi over 4. That's our first angle, but if we went all the way around the circle, we'd end up in that same spot, giving us the same y value. So it's another possible answer. So adding 2 pi n. So this whole thing here, that's our final answer. Now again, that's for radians. If we wanted to do degrees, it'd be a pretty similar process. You find the y values for, or the y values that come out to be root 2 over 2. The angles in degrees are 45 degrees and 135. So 45 degrees, 135 degrees. And now if you're working in degrees and you want to move all the way around the circle, you would add 360. So we're going to add 360 times n for both of those original values. And so then you can have all the possible values of sine inverse root 2 over 2.